Hi, we are going to talk about exponential and logarithmic functions and how to switch back and forth from one to the other. They're inverse functions of each other, so just like x cubed and the cube root of x, they undo each other, and you can write them in different ways. So if you look at the second bullet here, x cubed equals 27. That means exactly the same thing as 27 to the 1/3 power equals x. Those are completely equivalent equations. And just like that, we can do the same thing with exponential equations. So 2 to the x power equals 16 is the same thing as log base 2 16 equals x. So the base is 2. And when we talk about logs, we usually talk about bases, but notice where the 2 starts out in the exponential function and where it ends up in the logarithmic function. So that's kind of that movement. The exponent in the exponential equation ends up being the answer to the logarithmic equation. And then the other number is just in the last spot. That's how I like to think of it. And when I look at these, I read the log equation as 2. I look at that little 2 and go 2 to the answer power equals 16. And it's kind of good. A lot of people use some kind of a motion to go with this, either a circular motion where you go from the 2 to the x to the 16, or a triangle, whatever, but something that gets you going from 2 to the x power equals 16. When you look at that log equation, it's really going to help you remember how this works. A lot of times you need to use, you're given one of those equations, but it's hard to solve that way, or maybe even impossible. So if you switch it to the other version, it's easy to solve. So we go back and forth quite a bit between those, and that's what we're looking at doing today. So here are some examples. You might want to keep pausing through this and working this out in your head as we go along, so you can see how this works. You will need a fair amount of practice on these to get it stuck in your head, and you need it to be stuck in your head because you'll be going back and forth quite a bit. So 5 to the x power equals 25 means the same thing as log base 5 of 25 equals x. So again, take that little number after the log. That little number raised to the answer power equals the other number. Y equals log base 8 of 2 means 8 to what power equals 2. And that power in this case is the 1/3 power because the cube root of 8 is 2. Y equals log base 7 of 1 means 7 to the y power equals 1. So here you have to remember that anything to the 0 power equals 1. So your answer is going to be 0. 6 to the first power equals x means log base 6 of x equals 1. So again, take that little number, raise it to the answer, you get the other number. And the inverse functionality of these is shown in the next two. So if you have 3 to the log base 3 of x power, that whole thing is the power. That just ends up being x because those inverse functions undo each other. And the last one, log base 17 of 17 to the x power equals x. Again, inverse functions, but notice that you have to have the same number. If this was log base 17 of 5 to the x power, the answer wouldn't be x. That base has to be the same number. There are two bases that are more important than all the others, base 10 and base e. Usually a calculator only has those keys for those two. Some calculators have a base 2, most do not. We do have a change of base formula if you have some other base between those where you can get from whatever that base is to base 10 or natural log base at any time. Base 10 is called the common log. If you see a log equation that with no little number next to the log, it means it's base 10. That's the default. Base 10 logs are used for the Richter scale for measuring earthquakes and pH. They're very important. So I've had professors from different areas call me and say, can you please boost students' knowledge of base 10 logs because they use them in my class later on. So that's a very important one. Base E is called the natural log. It's usually written with a lowercase l and a lowercase n for logarithmic natural. And its base E is used in some financial applications, and you can use it for solving any log equation as you can the common log, but natural log is used more often, but not for any specific reason. And so you want to take out your calculator, find the 10 to the x log. Those are usually second functions of each other and on one key, and then e to the x and natural log keys on your calculator. And then I would go back to the previous slide, so just go back and pause and put those equations in your calculator and figure out how to get the answers that you need by using those keys. And that's it. And again, a lot of practice is needed for this because you gotta just have it down like 2 + 3 = 5. That's all. Thanks. Bye.